This video, we are going to be talking about how we use rational numbers in real life. You've already watched one video about this, and that one was specifically about when we add and subtract in real life. This video is going to be about when do we see multiplication and division in real life. So our first problem says, Miss Neville is baking 5 batches of cookies. She will need 2½ cups of flour for each batch of cookies. If she begins with a 20 cup bag of flour, what is the resulting change in the amount of flour in the bag? Okay, so we know that she starts with 20 cups of flour. And we know it's 2½ cups per batch. Okay, so what do we need to know? We want to know the change in the amount of flour in the bag. All right, so it says that she's baking 5 batches of cookies. Okay, so we know that we are going to have the number 5 in our problem. So we're going to multiply the number of batches that she's going to make with how much flour is in each batch. Okay? So the first thing that we have to do is we have to make our whole numbers and our mixed numbers into improper fractions. And so to do this, we put 5 over 1, and then we do 2 times 2, which is 4, plus 1. So 5 over 2. So now when we're multiplying fractions, we just do top times the top and the bottom times the bottom. So we get 25 over 2. So now we're going to turn that back into an into a mixed number, and we get 12 and 1/2. So that means that when she is making these cookies, she's using 12½ cups of flour. Okay, so the change is there will be 12½ less cups of flour in the bag. Okay, so remember when we go from a mixed number to from an improper fraction to a mixed number, you ask yourself, how many times can 2 go into 25? Well, 2 can go into 25 12 times. There's 1 left over when we do that, and so then we use our denominator still. All right, next problem. So it says, think through the situation, then follow the rules for integer operations. It says draw a number line or a model. You don't have to do that. I'm not looking for that. But sometimes drawing a picture can help you visualize the situation. It says Jody has 6 1/4 pounds of candy to use to make Valentine's goodie bags for her classmates. If she puts 3/8 of a pound of candy in each goodie bag, how many Valentine's bag can she make? Okay, so she has 6 1/4 pounds of candy. 3/8 of a pound in each bag. So it says, what do we need to know? We want to know how many goodie bags she's going to have. Okay, so if you think of this problem, she's starting off with 6 1/4. Okay, so she's starting off with her big number. and then she's going to take a little bit of each of that big number and put it into a goodie bag. So we are dividing that 6 1/4 pounds of candy into smaller sections, and so this is a division problem. So we have 6 1/4 divided by 3/8. Okay, so the first thing we need to do is this needs to become an improper fraction. So we get 25 over 4. I did 6 times 4 plus 1 divided by 3/8. Okay, so when we're dividing fractions, we keep it, we change it, we flip it. Okay, so 25 over 4 times 8 over 3. And that equals 200 over 12. All right, so we need to go from a mixed number back to, we need to go from an improper fraction back to a mixed number. So to do that, we're doing 200 divided by 12. So how many times can 12 go into 20? It can go in there 1 time. That is 12. 8, bring down our 0. How many times can 12 go into 80? It can go in there 6 times. That is 72. And that has 8 left over. So our number is 16 8/12. Okay, that can be simplified even more. Both of these numbers are divisible by 4. So that is 16 2/3. Okay, so this didn't come out equally, obviously. So our solution is there will be 16 full goodie bags. Okay, there will be a 17th goodie bag, but it's not going to be completely full. It's only going to be 2/3 of the way full. All right, next problem. Avery bought 6.5 pounds of produce. If the produce was priced at $1.88 per pound, how much did Avery pay for the produce? How much change did she receive if she paid with a 20? Okay, so that we know she bought 6.5 pounds. We know it was $1.88 per pound. Okay, what we want to know is how much change will she get back? All right, so remember we made that little sheet that said it had the plus sign, the minus sign, the multiplication sign, the division sign. So one of the words on there was per, okay? And that word tells us that we need to multiply. So what we are doing is we are doing $1.88 times 6.5. So we do 5 times 8, 0. Carry the 4, 5 times 8, there's a 4, and a 4. 5 times 1 plus 4 is 9. Okay, we bring down a 0. 6, these go away. 6 times 8 is 48. Again, 6 times 8 is, there should not have been a decimal there. 6 times 8 is 48, plus 2 okay, is 52, sorry. 6 times 1 is 6, plus 11, or plus 5 is 11. So now we have to add all of this together. Get 0, 2, another 12. Okay, so we have 1, 2, 3 numbers after decimals in our problem, so it needs to go 1, 2, 3 over. So we get 12, 22. All right, so that's not the end of this problem. So the end is how much change is she going to get. So we have to do $20 minus 12.22. To borrow from this, that makes it a 10. Okay, so we get 8, 7, 7. Okay, so she is going to get $7.78 in change. Okay, I know I'm going through these problems kind of quickly. If you have questions, please don't hesitate to ask. All right, so the last one says a container of rainwater is evaporating at 1.2 centimeters a week. After 8 weeks, what will the change in the rain level? I'm sorry, I cannot read today. A container of rainwater is evaporating at 1.2 centimeters a week. After 8 weeks, what will be the change in the rainwater level? Okay, so it's 1.2 centimeters less per week. Okay, because evaporating, that means that the water is going away, so the amount is getting smaller. Okay, so we want to know what will be the change, after 8 weeks. Okay, so again, we have the word per. Per means we're going to multiply. So 1.2 times 8. Okay, 8 times 2 is 16. Carry the 1. 8 times 1 plus 1 is 9. We only have one number after a decimal point, so there's only going to be one number after a decimal point. Okay, so it's going to be a negative 9.6 centimeters. Okay, so what that means is after 8 weeks, there will be 9.6 centimeters less rainwater than there was at the beginning of the 8 weeks. All right, so you are going to grab the quick check that says how can rational numbers be used in real life.